We're going to be talking about domain and range of new functions. And when we were dealing with polynomials, the domain of a polynomial is always all real numbers. Because no matter what polynomial you create, x to the fifth plus 7x squared plus 3x plus 1, no matter what polynomial you create, you're allowed to plug in any x value. And that's true for many functions. So instead of talking about the domain of those functions, let's talk about, can I use equations to turn real numbers into non-real numbers? There are only two ways to start with real numbers and use real number equations to create non-real numbers. Can you think of any? If we square root a negative number, that is not a real number. It's an imaginary number. Can you think of any other way to create non-real numbers? Well, pi is a real number. So 6 times pi would be 6 pi. It's irrational, but it's still a real number. So that's not one of them. Okay, so if I had like negative 4 raised to the 1/2, which is exactly like this. Are there sometimes are you allowed to take roots of negative numbers? Are there some roots that will work? Can you think of any roots that do allow negative numbers? Kind of a poorly phrased question. The third root. The third root of negative 8 is what? Negative 2. Why does this work and this does not work? Two negatives multiplied together would be a positive. 3 negatives multiplied together would be negative. So in general, what's the rule on which roots create i's and which ones don't? Even roots create i's. So if I did the 65th root of negative 7, does that number exist on the real number line? Yes, because 65 is odd. If I did 650, then I would create an I. An I, right. Anytime you even root a negative, you create an imaginary number. Glad you came to school today, then. You are the first person I've taught anything to all day. Okay, so square roots, fraction, exponents, they're the same thing, basically, just in different forms. Is there any other way to get error on your calculator? Well, if you do a syntax error, right? I mean, if you did 6 plus 7, it's going to give you error. But there's one more rule we're not allowed to do that creates non-real numbers. Fraction to the power of fraction would work as long as it's not an even root and the fraction's negative. It has nothing to do with exponents. This is the only exponent problem you're going to run into. Anytime the denominator of your exponent is even and the number you're taking the root of is negative, then we get i's. Okay? What about this? That will give you an error. Now, in algebra, it gives you an error. In calculus, this is a perfectly acceptable number. What is 1 over 0? It's not 0. It's not imaginary. It's also not real, meaning it's not on the number line. So let's consider a couple things. 1 divided by 1 means how many 1s are there in 1? 1. 1 divided by 1/2 means how many 1/2s are there in 1? So this is 1/2 plus 1/2. And how many of these are there? 2. So 1 over 1/4 would be 4, because it's 1/4 plus 1/4 plus 1/4 plus 1/4. Okay? What about 1 over 100? 100. What that means is there are 100 1/100ths in 1. Does that make sense? There are 100 of these in here. That's all division is asking. How many of these are there in there? Okay? 1 over 1 million would be 1 million. So let's follow the pattern. As the bottom gets smaller, the answer gets bigger. So if I had 1 over 0.1, right, it's going to be 1.0 e to the negative 25 or something like that, right? Or I mean this number. So 1 divided by this is going to equal 1 e to the 25th. So as that number has 25 zeros behind the decimal, this one will have 25 zeros in front. Well, actually, it's 24 and 25, but no big deal. This number is huge, right? So following that logic, how many of these are there in there? An infinite number. So 1 over 0 is simply infinity. So why does your calculator say error? Because calculators display numbers, and it's just not big enough. Your calculator will only go to 9.9 e to the 99. Well, what is this compared to that? Nothing. So your calculator says, forget it. I'm too lazy to calculate that number, and it gives you an error. But it's really infinity. And infinity math is super fun. You ready? Infinity. Right? Oh, let's do some more of this. Infinity minus 10. Infinity. So 2 times infinity is infinity. Infinity divided by 60. Infinity. Ooh, I like this. How about negative 2 times infinity? Negative infinity. Right? Okay, here's a hard one. Infinity minus infinity. We don't have enough information. Because not all infinities are the same size, right? All infinities are created equal, but some infinities are more equal than others. Anyone read that book? Animal Farm? All animals are created equal, right? But some animals are more equal than others. So this is a problem because, I mean, you can see here, which infinity is bigger, this one or this one? The left one is bigger, right? It's 2 infinities. They're all infinity, right? But this one kind of gets to infinity faster than this one does. Well, there are actually ways to prove that some infinities are larger than others. Okay, so this is a problem. If those infinities are the same size, the answer would be 0. If the left infinity is bigger than the right infinity, the answer would be infinity. If the right infinity is bigger than the left infinity, it would be negative infinity. So, but in calculus, there are usually ways to figure it out. There are usually ways to tell which infinity is bigger because infinity, these are usually equations that are going toward infinity. And so you just measure how fast they're going toward infinity. Like the equation, if I had the equation 2x plus 1, that's growing toward infinity. And then if I had the equation 60x minus 5, this one is obviously growing much faster than the other one. And if you compare those two affinities, you can figure out which is bigger. Okay, it's not always capable to do, but we do this sort of math in calculus practically every day. Okay? But that infinity minus infinity is a little bit of a problem, just like what is 0 divided by 0? It depends on how big your 0 is. Some zeros are bigger than other zeros. And what I mean is, this is not the number 0. It's like if I had an equation that's getting closer and closer to 0, like 0.8 to the x, as we go out toward infinity, that graph is getting closer to 0, right? Well, if I had another one that was 0.3 to the x, it's going to be going really fast. So as we travel to the right, one of the zeros is achieved faster than the other one. Now, are they ever actually going to be 0? No. But one of them gets closer to 0 faster than the other one does. So we're not actually comparing numbers in this case. We're comparing equations. And if you can tell which one is bigger, it could be infinity or it could be 0. Or I mean 1, right? 0 over 0 could be 1. It could be 0. Or it could be infinity. Just depending on how big your 0 is. So calculus is an amazing math class. I mean, by far the favorite math class I've ever taken in my whole life. Calculus is super simple. You might have a 5-minute problem, 20 seconds of it is calculus, and then the other 4 minutes and 40 seconds is algebra and trig. And that's where the hard stuff is. The algebra and the trig is way harder than the calculus, usually. There are some calculus things that are tough to do, but then we just turn them into polynomials and make it easy. I could teach you the basics of calculus in 20 minutes. You could do polynomial calculus in 20 minutes. No. But the trouble is, without the algebra and trig skills, you can't do much with it. Okay, so you might wonder, why did I bother talking about this? And you'll see a little bit later. So we're going to deal with square roots today. So if I had y equals the square root of some equation, okay, I know two things. There are only certain numbers I'm allowed to plug in, right? So this parenthesis, I know something about the contents of this parenthesis. It's anything from 0 to infinity, right? So the parenthesis is greater than or equal to 0. Because if the parenthesis is a negative number, I get an I, and I can't graph i's. Okay? Well, what do I know about this? What sort of numbers come out of square roots? So here we're looking at the inputs. If we look at the outputs, what do I know about the outputs of a square root? What's the range of the outputs? Can I get a negative number? Can you square root a number and get a negative number? No. Can I square root a number and get a 0? Yes. Can I square root and get a positive number? Yes. So the output is also greater than or equal to 0. Okay? So if I had y equals the square root of x plus 3, and I wanted to know the domain and the range, it's easy. All I need to do is say this piece, the input portion, has to be greater than or equal to 0. So I say x plus 3 is greater than or equal to 0, and I solve for x, which gives me x is greater than or equal to negative 3. Now, let me show you why that's the case. Can I plug in 2? 2 plus 3 is 5. Can I square root 5? Yes. Can I plug in 0? 0 plus 3 is 3. Square root of 3 is, I don't know, some number. Can I plug in negative 2? Negative 2 plus 3 is 1. Can I square root 1? Yeah. What about negative 3? Negative 3 plus 3 would be 0, and the square root of 0 is 0. Okay, can I plug in negative 4? No. Negative 4 would give me a negative 1, and I cannot square root negative 1. So the input values are restricted. I'm only allowed to plug in numbers from negative 3 up. Okay? What about the output values? The range. So whatever happens on the inside, when I take the square root, what sort of numbers am I going to get? Positive and 0. Right? So the range here is everything from 0 to infinity, including 0. Right? So whatever happens here, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. I can put in any number, well, I can get out any number from 0 to infinity. Well, you're always going to have some kind of infinity here on your range. Okay? So let's look at this. Okay? And let's do... So, if I want the domain, I set this greater than or equal to 0. So 2x minus 5 is greater than or equal to 0. I add 5. 2x is greater than or equal to 5, and I divide by 2. X is greater than or equal to 2.5. 2.5 is my breaking point. Right? As long as this number is bigger than 2.5, my square roots will be positive. If the number drops below 2.5, then I take the square root of a negative number, which is imaginary, and I can't graph that. Does that make sense? Riley, you stuck? So I set this greater than or equal to 0, and 2.5 is the breaking point. If I plug in 2.5, 2 times 2.5 is 5, and 5 minus 5 is 0, and I can square root 0. If I plug in a bigger number, like 3, 2 times 3 is 6, and 6 minus 5 is 1, can I square root 1? Yeah. If I plug in something smaller than this, like 0, 0 minus 5 is negative 5, can I square root negative 5? So I'm only allowed to use x values that are bigger than this number. Okay? Well, that's for the range. So we'll talk about the range right now. So for the domain, what? No, it's not. So if you want to know the domain of a square root function, you set the inside of the square root greater than or equal to 0. If you want to find the range, you look at what happens outside the square root. So the range of this is always 0 included to infinity. But once the square root happens, other things happen. We're subtracted 6. Yes, this is always the range of a square root. And then you have to adapt it to match the rest of the equation. No, there's one range. No. We're not finished with the range because this is not the only part of the equation. It's this minus 6. So I'm going to subtract 6 from both of these, and my new range is negative 6 to infinity. Right? Without this piece, the range would be 0 to infinity. But all of these values get subtracted by 6, so that brings the range down. -6 to infinity. Yes, Aaron? Yes. Yeah. So you take these numbers and you do whatever this says. Okay? So let's look at another one. Let's do 2 square root of 1 minus 3x plus 5. Y equals. Okay, so domain is easy. I set this greater than or equal to 0. So 1 minus 3x greater than or equal to 0. How do I solve this? Minus 1, negative 3x greater than or equal to negative 1. Divide by negative 3. X is, somebody remembers, we just divided by negative. You flip the inequality. The reason you do that, watch this. So let's say I had negative 2x is greater than 4. Divide by negative 2. X is less than negative 2. That's the answer. The reason is inequalities are not equal, so one side is bigger than the other. So if I move this over here using addition, plus 2x, and I move this over here using subtraction, I get negative 4 greater than 2x, and I divide by 2, and I get negative 2 greater than x. And notice this now matches that. So what we really did was we took our negative x and we switched it to the other side. It turned in from a greater than to a less than. So anytime you multiply or divide by a negative, you flip the inequality, which saves you a bunch of work of doing it the long way. So it was a greater than, now it's a less than. So if you look at this, this is my restrictive domain. So could you use negative numbers here? Well, negative 6 is less than or equal to 1/3. So let's see. 1 minus 3 times negative 6. That would be 1 plus 18, which is 19. So in this case, negative numbers are allowed because they create positive numbers in the root. Okay? So that's my domain. X is less than or equal to 1/3. For the range, I look at the range of the square root. So the range of this piece is 0 to infinity. Right? Well, what happens to that range? It gets times by 2. 2 times 0 is 0. 2 times infinity is infinity. What's really happened is we've taken the range and we've stretched it vertically by 2, which doesn't change anything. Okay? And then we add 5. 0 plus 5 is 5. Infinity plus 5 is infinity. So the range is y equals 5 to infinity. We'll talk about that in just a second. The 2 will change the graph. It will turn a graph like this into a graph like that, but they have the same range, right? They both go from here to infinity. One just goes faster than the other, and range doesn't care how fast things happen. Hang on, we're not there yet. Okay, what about this? What would the domain be? The domain is from 0 to infinity. X is greater than or equal to 0. For the range of this piece is 0 to infinity. And I times that by negative 1/3. What happens? Well, negative 1/3 to 0 is 0. What is negative 1/3 times infinity? Negative infinity. Can I write my range like this? That doesn't make any sense. It says the smallest number is 0 and the biggest number is negative infinity. I'd have to flip it. So the range is y equals negative infinity to 0. Right, so now the original range would be from 0 up to infinity, and the new range is from 0 down to negative infinity, but you have to start from negative infinity and go up to 0. Okay, what about cubed roots? Is there any number I'm not allowed to plug in? I can do positive numbers, I can do negative numbers, I can do 0. So the domain of a cubed root is all real numbers. Well, if the domain of a cubed root is all real numbers, what is the range of a cubed root? It's also all real numbers, because if I do the cubed root of a negative number, what do I get? All possible negative numbers. If I do the cubed root of a positive number, what do I get? All possible positive numbers. So if you have this, the domain is all real numbers and the range is all real numbers. What if I jazz it up? 6 plus 2 minus 5 plus 8. What's the domain? Well, the domain was negative infinity to infinity. If I take negative infinity to infinity and I double it and I subtract by 5, what do I get? Negative infinity to infinity. If this is the range and I add 6 and add 8, nothing happens. So if it's a cubed root, the range is all real numbers and the domain is all real numbers. Okay? So always. Yep, without doing any work, it's always all real numbers. What about a fourth root? How would you treat a fourth root? Just like you would a square root. It has the same don't square root a negative rule. What about a fifth root? It's the same as a cubed root. What about a sixth root? Same as a square root. So on this worksheet, you need to find the domain and the range, and then on a bunch of them you need to graph. Now, on 5 and on it says sketch the graph. I want you to find the domain and the range and then sketch the graph. So just graph it on your calculator. But you need to find the domain and range on all of the problems, not just the ones that it says find domain range. Okay? It's a really simple worksheet. It shouldn't take you too long to do. Here are the answers. Good luck.